Okay. So 3 or more lines that intersect, they're concurrent. The point at which they intersect is the point of concurrency. We're going to take a look at this picture. What is segment EG? Look at it. What is it? It's a perpendicular bisector to AD. What is EF? A perpendicular bisector to CD. And what is EB? It's a perpendicular bisector to AC. E is that point of concurrency of the 3 perpendicular bisectors. E is the circumcenter. Here's what the theorem says. The perpendicular bisectors of a triangle intersect at a point called the circumcenter. Point E in this case. It is equal distance from the vertices. In other words, if I go from A to E, if I go from D to E, and I go from C to E, what can you tell me about all those values? They're all going to be equal. They're congruent segments. If you have the point of concurrency of perpendicular bisectors, it is called a circumcenter, and it is in fact the same distance from the circumcenter to each one of the 3 vertices of a triangle. Questions so far? Here's our first example then. And again, we're going to modify the picture a little bit. Obviously, all of these that were marked with 1 mark aren't the same. So on the side where DC is, we're going to mark it with 2. The side where AC is, we're going to mark each side with 3. What is segment EG in the picture? Perpendicular bisector. What is segment EF? Perpendicular bisector. What is segment EB? What does that make point E? It's the circumcenter. If E is the circumcenter, what does that tell me about AE, DE, and CE? They're all equal to each other. Which 2 do I want to use to start with?
4x plus 3 and 3x plus 6.
I definitely want to use 4x plus 3 and 3x plus 6 because this way I only have 1 variable instead of having to deal with 2. I'm going to go ahead and subtract 3x from both sides. I have x plus 3 equals 6. If I subtract 3 from both sides, I have x is equal to 3. That takes care of x, but what would I do to find y?
You would put 2y plus 1 equals 3x plus 6 and then plug 3.
It doesn't matter what I set it equal to. In fact, I'm going to plug this in before I take it out of the picture. What is 3 times 3? Plus 6. So this segment is 15, which means this segment is also what? And it means this segment is also what? 15. Which is exactly what I did. I took 2y plus 1, set it equal to 3x plus 6, But what did I replace x with? 3. And I'm going to solve it. I'm going to subtract 1. 2y is equal to 14. I'm going to divide both sides by 2. And y is equal to 7. If you have a circumcenter, the point of concurrency of the perpendicular bisectors of a triangle, that circumcenter is the same distance from each of the 3 vertices. Everybody okay with this example? The point of concurrency of angle bisectors of a triangle is called the incenter. I can see this line here is an angle bisector. This one is an angle bisector. So is this one. So in each one of these pictures, that point of concurrency is the incenter. Did they mark this as being 90 degrees? No. I don't know that for sure. And they didn't mark it as bisecting the segment either, did they? There is a case where the incenter and the circumcenter are in fact the same. But equilateral comes up the same. So in each one of these pictures, that point of concurrency is the incenter. And here's what it says. An incenter is equal distance from each side of a triangle. And I want you to be able to see that E is an incenter. So let's go ahead and mark that this AE bisected this angle. That DE bisected where angle D is. And that CE bisected the angle that was here. So that we can see that E is the, in fact, incenter of this triangle. Notice it says equal distance from the sides. Since we're talking about distance, distance to the side of a triangle has to be measured so that it forms what type of an angle? A right angle, which is why this is 90 degrees. Question?
Okay, I thought that it was an incenter and it didn't tell you that they were a right angle.
It didn't.
But it did.
No, look. This is the incenter. The distance from the incenter, from here to here, that's a distance. We're drawing that in as a dotted line. We're saying this distance, and this distance are in fact what? They're all equal. If you know it's an incenter, and you can find the distance to the side, that if I take EG, and I compared it to EF, and I compared it to EB, in fact, all of those would be what? The same. Now notice it didn't say anything about bisecting this segment, did it? It just says that if I come from E to this side so that it makes a right angle, it's a distance, that those distances from the incenter will in fact all be then the same. That whatever this is, this will be the same, and this will be the same. Question? Anybody? Question? Here's what it looks like as an example. And again, let's make sure that you mark your angles showing that it bisected this angle, that it bisected where D is, and that it bisected where C is. So that we can see that AE is an angle bisector, DE is an angle bisector, and CE is an angle bisector. And because they are angle bisectors, what is E in this picture? E is the in-center. If it's an in-center, it's the same distance from the sides. So in other words, EG, EF, and EB are in fact all equal to each other. Which two do I want to use this time? I want to use 3x is equal to 5x minus 30. Because I can see that there I have the same variable. I'm going to go ahead and subtract 5x from both sides. Negative 2x is equal to a negative 30. And I'm going to divide both sides by a negative 2. X is equal to 15. What should I do with that 15? Plug it back in. What is 3 times 15? 45. So each one of these segments should be 45 units long. And there is my other equation. 4y minus 1 is equal to 45. If I add 1 to both sides, 4y is equal to 46. If I divide both sides by 4, y is equal to 11.5. Are there any questions? We all good? It actually starts on page 127 of your workbook then. The STP stands for Standardized Test Prep. That's on page 129.